Hello everyone, welcome to the lecture. Myself Bullet Devanandra, working as Associate Professor in the Department of CSC, MLR Institute of Technology, Hyderabad. The problem is, draw a DFA for the language accepting strings with 0, 1, 1 as substring over the input alphabet 0, 1. So, input alphabet is 0, 1, substring. The given string will contain substring 0, 1, 1. Valid strings are, so the 0, 1, 1 is a substring. The substring may occur at the beginning of the string or middle of the string or end of the string, anywhere, that is 0, 1, 1 here or here or here, any position in the string, beginning of the string or end of the string or middle of the string. So, valid strings are 0, 1, 1, 1, 1 is a valid. So, beginning 0, 1, 0, 1, 1, 0, middle, end. These are the valid strings. Anywhere you can find the sequence 0, 1, 1 is a substring. For that, we need to draw the prefixes of 0, 1, 1 are 0, 0, 1, 0, 1, 1 prefixes. So, initial state is Q0. If you read 1, stay in the same state because 1 is not prefix of 0, 1, 1. If you read 0, I can go to next state. Forward, moving towards next state Q1. So, 0 is prefix of 0, 1, 1. Next, if you read 0, 0, 0 is not prefix of 0, 1, 1, but 0 is prefix of 0, 1, 1. So, that stay in Q1 because 1 is meant for prefix 0. If you read 1 in Q1, that means current symbol is 1, previous symbol is 0, that becomes 0, 1, that is prefix of 0, 1, 1. So, that next state, going to next state. So, in Q2, if you read 0, that means previous symbol is 1, current symbol is 0, that is 1, 0 is not prefix of 0, 1, 1, but 0 is prefix of 0, 1, 1. So, that I go back to Q1 for 0, Q1 is meant for prefix 0. If you read 1 in Q2, that means previous two symbols are 0, 1, current symbol is 1, that is 0, 1, 1. So, that I go back going to final state Q3. Once you see substring anywhere beginning or middle or end, after that you can read any number of zeros and ones, say in the final state only. This is the transition diagram. So, string processing Q0 is the initial state, take string 1, 0, 0, 1, 1. So, Q0 on 1 going to Q0, remaining string 0, 0, 1, 1. Q0 on 0 going to Q1, remaining string 0, 1, 1. Q1 on 0, Q1, remaining input 1, 1. Q1 on 1, Q2, remaining input 1, Q2 on 1, Q3. Q3 is the final state. The string is accepted. Next, draw a DFA for the language accepting strings with BAB as substring over input alphabet 0, 1. Substring anywhere, BAB is anywhere in the string, beginning of the string or end of the string or middle of the string, anywhere. Prefixes are B, BA, BAB. So, initial state is Q0. If you read B as a prefix, so that I can go to next state Q1. If you read A, stay in the same state. In Q1, if you read A, that is BA is the prefix, going to next state Q2. If you read, instead of A, if you read B, because B is a prefix, stay in the same state Q1, Q1 is meant for prefix B. In Q2, if you read B, that is BAB, we have seen the substring BAB, so that I go to final state, that is Q3. Once we reach final state, that means we have seen substring BAB, so that for any symbol A and B stay in the same state. But in Q2, if you read A, where you have to go? Previous symbol is A, current symbol is A. A is not prefix of BAB, and A is also not prefix of BAB. So, that you go back to initial state for A. Like that, we have to draw the transition table, transition diagram. Transition table is Q0 is the initial state, Q1, Q2, Q3. Q3 is the final state. Inputs are AB. Q0 on A going to Q0, Q0 on B going to Q1, Q1 on A going to Q2, Q1 on B going to Q1, Q2 on A going to Q0, Q2 on B going to Q3, Q3 on A going to Q3, on B going to Q3. Next, design a DFA such that the language containing a power n, b power n, such that n and m both are greater than or equals to 1. Both are greater than or equals to 1. That means n number of a's followed by n number of b's. So, number of a's, number of b's may not be equal, but the order is important. First a's occurs, then b's. Then b's. The string should begin with a, should end with b. The string begin with a. String begin with a and end with symbol b. The string should begin with a and end with b. The string should not begin with b because a is followed by b's. If the first symbol is b, invalid. If the last symbol is a, invalid. So that the initial state q naught, if the first symbol is b, that is invalid, go to dead state. First symbol is b, that is invalid. Last symbol should be b, should not be a. Once you reach dead state, for any a and b, stay in the same state. If the first symbol is a, valid, go to next state q1. There you can read n number of a's. First symbol, after reading first symbol, that is a, first a, I can go to q1. There you can read n minus 1 number of a's, stay in the q1. Then in q1, after a's over, b's starts. If the first b after a's, I can go to final state q2. There in q2 you can read n minus 1 number of b's, but last symbol should not be a. In q2 if you read a, going to dead state. Then q0 is the initial state. Take a valid string a, bb is a valid string processing. q0 on a going to q1, remaining a, bb. q1 on a going to q1, remaining input bb. q1 on b going to q2, remaining input b. q2 on b, q2. q2 is the final state. Take another invalid string q0 a, b, a. q0 on a, q1, q1, remaining input ba. q1 on b, q2, remaining input a. q2 on a going to dead state, non-final state. String is not accepted. Non-final state, string is not accepted. Draw a DFA for the language accepting strings containing exactly 2 zeros over input alphabet 0, 1. Exactly 2 zeros. The string should contain exactly 2 zeros. Exactly. Not more than 2 zeros. Not more than 2 zeros. Like this 1 0 1 1 1 1 0 is a valid. 0 0 1 0 is invalid. 1 1 1 1 0 0 is valid. 0 0 1 1 1 1 is a valid. 0 0 0 0 is invalid. So exactly 2 zeros, but position of zeros is not important. Count is only important. Count should be 2 zeros, not more than 2. Combination any place, the position of zeros may be consecutive zeros or non-consecutive zeros, but count must be 0, 2 zeros. So initial state q0. So if you see first symbol as 0, I can go to q1. If you see 1, stay in the same state. So count starts. So that first 0 I have seen. If you see in q1, if one more 0, count I have seen 2 zeros, go to final state. I have seen 2 zeros. In q1, if you read 1, stay in the same state, because only zeros matters. You can count zeros only. In q2, if you read one more 0, that is zeros becomes more than 2. So that I can go to non-final state Q3. In Q2, if you read 1, stay in the same state Q2, because up to Q2 we have seen only 2 zeros. You can read as many number of ones. There is no restriction on ones, only restriction on zeros only. Once you reach Q3, that means you can write a dead state. D is a dead state. Once you reach a dead state, you cannot come out from dead state for any number of zeros and ones. So string processing, Q0 is initial state, take 1 0 0 1 is a valid string, Q0 on 0, Q0 on 1, Q0 only, remaining input 0 0 1, Q0 on 0, Q1, remaining input 0 1, Q1 on 0, Q2, remaining input 1, Q2 on 1, Q2, final state. String is accepted. Thank you.